All right. Here's a quick little video for you on drawing Lewis structures with polyatomic ions. So polyatomic ions, that list, I gave you a list of 24. There's more than that for you to be learning, memorizing. Remember, polyatomic ion is a group of covalently bonded atoms. That's what a polyatomic ion is. Remember, an ion is just an atom or a group of atoms with a charge. What we call a group of atoms with a charge is a poly, meaning many, atomic, meaning atoms with a charge. So it's a group of atoms that are bonded together through covalent bonding, meaning they're sharing electrons, right? And the whole group has a charge. Not one of the individual atoms, but the whole group has a charge. So it is a polyatomic ion. As far as doing the Lewis structures for them, it is pretty much the same thing, but I wanted to do a quick little video showing you those. I know there's some problems for you to do. So the first one is ammonium NH4. And NH4 has a positive charge, or a +1 charge. If there's no number up here, that means that it's understood to be a 1. Okay? So if we're doing the structure for this, then we say, okay, we've got one of these, we have 4 of these. In terms of nitrogens, we know nitrogen has 5 valence electrons in group 15, and then hydrogen has 1 valence electron, but there's 4 hydrogens. That gives me a total of 9. But then I got to take into consideration that would be if that was neutral, right? But this is not neutral. It actually has a positive charge. If it has a positive charge, that means that we have lost an electron. I mean, we have more positive stuff than we do negative stuff. Electrons are negative, right? Giving us a positive charge. So we've lost 1 electron if it's got a positive 1 charge. So we need to take that in consideration by subtracting 1 electron. Remember, this is the number of electrons. Positive charge means we've lost an electron. So we've actually got 8 electrons that we're working with, okay? So that is one of 2 differences when we do these Lewis structures for polyatomic ions. I just have to take that in consideration when I'm doing step 2. How many electrons do I need to add or take away from the system based on what this charge is, okay? So hydrogen can't be in the center, so we've got to have the nitrogen in the center, and then when I draw my structure, there's 4 hydrogens, so I just go around it, 4 hydrogens just like that. And really, I'm pretty well done, right? Once I build my skeletal structure, hydrogens are set and forget it, they're dead ends. Step 4 would be to make sure that everybody has 8 that needs 8. Nitrogen's got 2, 4, 6, 8, so that's good. As far as the total number of electrons that I have, 2, 4, 6, 8, I'm supposed to have 8, so that's it, all right? I'm done. Except the last thing, the other difference with polyatomic ions, to let everybody know that this is an ion I drew the structure for, we take and we draw brackets around the whole structure, and up here in this upper right corner, we put what the charge of that is, okay? So all these other ones that we've been doing, they're molecules that are neutral, so we don't have to worry about this whole bracket and charge thing, okay? But when we're doing polyatomic ions, we do the brackets and we do the charge to let everyone know that, hey, that's an ion that we're working with. That's a polyatomic ion. Okay? I'll do one more of these, and this video will be brief. I know you're excited about that. So I could do OH, but I'm not. It's really simple. You guys can do that. You can try that on your own. You can let me know if you have any trouble with it. It might even be one of the problems in the worksheet. What we're going to do is we're going to do nitrite, NO2-. Okay? This is one of the ones that was on your list. Okay? So nitrogen, once again, how many valence electrons? 5. Oxygen, how many valence electrons? 6. But there are 2 oxygens here, so 2 times 6 gives me 12, plus the 5 gives me 17. Right? If I get an odd number for the total number of electrons, it's either a weird case, or I've done something wrong, or I haven't finished my problem yet, because I still got to take into consideration the charge of the ion, right? Which is the case here. So I have to take into consideration the fact that this whole thing has a negative charge. In fact, a -1 charge, because there's no other number there. If it has a negative charge, that means it's added electrons. So here's our electron count. We need to add that other electron. So we actually have 18 electrons that we're working with as we build this structure. All right. Nitrogen and oxygen, we don't have a carbon, so which one's going to go in the center? If you look in terms of electronegativity, this guy has electronegativity of 3. Oxygens have electronegativity of 3.5. So the nitrogen is the least electronegative, so it would be the one that goes in the center. A quicker way in my mind of doing that is just thinking, how many bonds does each of these guys want? Nitrogen wants 3 bonds. It's got 5 electrons. It wants 3 more, so 3 bonds give it that. Oxygen has 6, so oxygen only wants, it's kind of hard to do that here, it only wants 2 more to get to 8, right? So it only wants 2 bonds. So nitrogen wants more bonds. It's probably the one in the center. All right? So you have your nitrogen and your 2 oxygens. Give everybody 8. 2, 4, 6, 8, 2, 4, 6, 8, and then 2, 4, 6, 8. All right? Everybody individually has 8. We're good there. If we check our total, we've got 8, 10, 12, 14, 16, 18, 20. We're supposed to have 18, so we have too many. If we have too many electrons, we reduce that by adding bonds. So since I have identical atoms on either side, it really doesn't matter which one I add to. So I'm just going to take the one that's closest to me. I'm going to take 2 electrons off of it, 2 electrons off of the nitrogen it's bonded with, and we're going to add a bond, and that's going to change our total number down to 18. 2, 4, 6, 8, 10, 12, 14, 16, 18. So our total system's happy. Now, this guy still has 8. 2, 4, 6, 8. This guy still has 8. 2, 4, 6, 8. But our total is now 18, what we want. So the only thing we've got to do to finish is bracket. And up here in this right-hand corner, put the charge of the polyatomic ion. It's a negative charge. Now, to go back to what we talked about just real briefly here, about how many bonds an atom wants. We said that nitrogen wanted 3 bonds, right? And it got 1, 2, 3. Oxygen wants 2 bonds, and it got 2. This oxygen, it wants 2 bonds. Did it get 2? No, it didn't. Okay? So, is this still correct? Yes. It has to have 8 electrons, 2, 4, 6, 8, or it wouldn't happen. So, it has what it has to have. It needs. It wanted 2 bonds. It didn't get it. This one did. Okay? So, there's that. All right? Good deal? Polyatomic ions, Lewis structures for polyatomic ions. Just make sure that you put the brackets around it and you take into consideration what the charge is when you're counting up the total number of electrons you're supposed to use.